Good morning, Algebra 2. This is Algebra 2, Semester 2, Apex 3.8 and 3.9. So the end of logarithms. So we've been talking about logarithms and how logarithms undo exponential equations or exponential expressions. So an exponential equation is an equation containing one or more expressions that have a variable as an exponent. So that's where you see we have some sort of variable as the exponent. To solve exponential equations, we can try two different things. We can try rewriting them so the bases are the same. So if I have, 5 to the x and 125, okay, then I'm going to try to get this so that my bases are the same. So I'll say, well, 5 to the x, I can't do anything with that 5, but 125. Well, I know that that is 5 to the third power. So now my bases are the same. And then when I raise, so then I can raise both of those to the same log, okay? And that would give me, let's see. So then those would cancel, and really I would just be left with my exponents equaling each other, okay? So that's one of the reasons we want to try writing them so the bases are all the same. The other one is we can either change it, we can change it to logarithmic form and then use our change of base formula, or we could change it, if we're going from logarithms to exponential functions, then we can rewrite it as an exponential function and try to solve it. Okay, so let's go ahead and work through some problems. So I have 8 to the x and 2 to the x plus 2. The very first thing I always try to do on any of these is I try to rewrite it so the bases are the same. So this is a 2 and this is an 8. Well, the 2, I can't get that any smaller, but the 8, can I make that as a 2 raised to some power gives me 8? Okay? That's what I'm looking for. Okay, so I know that 2 to the third power equals 8, so that becomes 2 to the 3 times x equals 2 to the x plus 6. Okay, so now I can rewrite this as log base 2 to 3x equals log base 2 to x plus 6, because remember these cancel each other out. Okay, and as you progress, you may not always want to write the, log base 2. You may just go, oh, well, these are going to cancel. Okay, so now we're going to set it up as 3x equals x plus 6. Okay, and now that's one that we can easily solve. So now we're going to subtract x from both sides, and we get 2x equals 6, and divide both sides by 2, and we get x equals 3. Okay, and if we do 8 to the third power, so I'm just going to check this. So 8 to the third power gives me 512, and 2 to the 9th power gives me 512. Okay, so I just plugged it back in to check it. So let's go ahead and take a look at the next one. So I have a 5 here. So the first thing I'm going to do is see if I can get that 200 to be 5 to some power. Okay, so on my calculator, I'm just going to try. Okay, well, 5 squared I know is 25. 5 to the third is 125. So then I'm going to try 5 to the fourth. Ooh, that's 625. So we jumped right over that 200. Okay, so in this case, I'm going to need to rewrite this. Okay, so I'm going to have, so remember when I rewrite this and this change places. So it becomes log base 5, and the x minus 2 and the 200 are going to change places. Now this I know how to do. It's that change of base formula that we did last time. Okay, so I'm just going to do log of my number here divided by log of my number here. Okay, and that'll give me a decimal. Okay, so I'm going to write it as log of 200 divided by log of 5 equals x minus, not x minus 5, equals x minus 2. Okay, so now when I plug this in, okay, I'm just going to plug this in. So log of 200, make sure you close those parentheses, divided by log of 5 equals 3.29. Okay, so 3.29 equals x minus 2. Add 2 to both sides, and I get x is about 5.2. Okay. So this is a 2. Sorry, you guys can't see that. I don't know if my eraser must be dirty. All right. Okay. So first thing, always try to make the bases the same. If that doesn't work, then rewrite it as a log and use the log change of base formula. So this one right here, I have a 3. Can I raise 3 to some power and get 27? Well, I know that 3 to the 3rd power is 27. Okay, so I'm going to leave this as 3 to the 2x equals 3 to the 3rd, which is 27. So remember, I'm changing the way it looks, but I'm not changing what it actually says. So now if I raise both of these to the log base 3, okay, then those are going to cancel, and I'm left with 2x equals 3 divided by 2, and I get x equals 3 halves. All right, let's take a look at this one. So I have a 7 there. So can I raise 7 to some power and get 21? No, I can't do that. Okay, 7 to the first power is 7. 7 squared is 49, jumps right over 21. Okay, so now I'm going to have to rewrite it. So that's going to become log base 7, 21 equals negative x. Okay, so now this, I can use my change of base formula. So log of 21 divided by log of 7 equals negative x. I'm just going to type that into my calculator. So log of, 21, close my parentheses, divided by log of 7. That gives me 1.56 equals negative x. So my x then is going to be approximately negative 1.56. All right, let's go ahead and take a look at this last one. So I have a 2 there. So can I raise 2 to some power and get 15? Okay, that's my question. No, I can't. Okay, it doesn't work. So I'm going to have to rewrite it as a log. So I'm going to have log base 2, 15 equals 3x. So these just traded places. And this became my base. Okay, my base always stays my base. Okay, so now I'm going to do my change of base formula. So log of 15 over log of 2 equals 3x. Type log of 15 divided by log of 2 into your calculator, and you get 3.91. Okay, divide by 3, and you get x is approximately 1.3. We're going to work on some more of these, but let's take a look at a word problem right now. So it says, suppose a bacteria culture doubles in size every hour, and we want to know how many hours. Okay? So the hours then is going to be our x. So how many hours will it take for the bacteria to exceed 1 million? So in other words, if it doubles in size every how many hours, okay, equals 1 million bacteria. So now this one right here, well, 2 to what power would give us 1 million? Okay, that would probably be a lot, so I'm not going to try that. So I'm going to rewrite this as a log. So log, there's my base, my 1 million and my x change places. Now I can use my change of base formula. And when I do that, I get approximately 19.93 hours. Okay. So it doesn't take very long for those bacteria to really increase. So you need to be sure that you know how to read this. Okay, so it doubles, that's where I got the 2 from, in size for every hour. Okay, so it's 2 to the x power. Okay, because what will happen is that first hour it'll be 2. The second hour it'll double and it'll be 4. The next hour it'll double and it'll be 8. The next hour it'll double and that'll be 8 times 8, which is 64. Okay. So you see that it's just continually getting bigger and bigger. Okay. All right, so let's take a look at some more problems here. Okay, these ones are a little bit more difficult. Okay, but we're going to use the same concept. Okay. So on these, the very first thing we're going to see if we can cancel anything. And then if we can't, then we're going to have to rewrite it. Okay, so let's go on ahead and take a look here. So here I have log base 3 x minus 5 equals 2. Okay, so this one right here, I can rewrite. Okay? or I can cancel. So I can raise this to, I can do 3 here and 3 here, okay? Or what I would like to do is just rewrite it. Okay, so this and this are going to change places, and my base is going to be my base. So 3 squared equals x minus 5. 9 equals x minus 5. So I get 14 equals x. Okay, it's done. If I had raised them both to a base of 3, I would have gotten the same thing. So this would have canceled, and it would have been x minus 5 equals 9. Right? Either way. Okay. So this one right here, remember, when there's a minus sign, it really means division. So let's simplify it first. So we have log of 45x over 3 equals 1. Remember, if there's nothing written down here, the base is 10. So now I'm just going to go on ahead and simplify this. So log 45 divided by 3 is 15. So I have log of 15x equals 1. So remember, this is base 10. So to get rid of that, I'm going to have to raise both of these, okay, to a base using a base of 10. So that's going to cancel, and I'm going to have 15x equals 10, okay, 10 to the first power. Okay, right. So now I'm going to divide by 15, and I get x equals 2/3. And if you didn't remember to divide right here, that's fine too. It would still come out the same way. You would just have to multiply by 3 after you raise it. So you would get 45x equals 30, and then divide by 45, and you would still get 2/3. So there's multiple ways to do it, but it's going to be easiest to simplify before you start changing everything. Okay, so let's take a look at this one right here. So this one I can do the exact same thing, okay, that I just did here. So I'm just gonna rewrite this as an exponential, I think. So these two things are going to swap places, and this is my base. So it's going to be 6 to the negative 1 equals 2x minus 1. Well, 6 to the negative 1 is really 1 over 6 equals 2x minus 1. Now I need to add 1 to both sides, but when I add it, I need a common denominator. So 1 is just 6 over 6. So now I get 7 over 6 equals 2x. Divide both sides by 2. Okay, so that really means that those combine together, and I get 7 over 12 equals x. Okay, so let's take a look at this one. This is subtraction. So the very first thing I'm going to do is combine. Okay, so I have 100 subtract. That means it's going to be over x plus 1. Okay, so now my next step equals 1. Okay, so I can't simplify that. So remember on this one, I said you don't have to simplify first. Well, on this one, you can't. Okay, so now I'm going to take and I'm going to raise both of these using a power of 4, or a base of 4, sorry. So it's going to be 100 over x plus 1 equals 4 to the first power, which is 4. Now I can start solving. So I got to get rid of this x plus 1. So I'm going to multiply it on both sides. So I get 100 equals 4 times x plus 1. And I could multiply it out if I want to. I don't have to. So whichever you prefer. So I'm just going to say 100 equals 4x plus 4. Subtract 4 from both sides, and I get not 99, I get 96 equals 4x. Divide by 4, and I get x equals 24. Okay. Okay, let's take a look at this one. Okay, 2 left. All right, so this one right here, we have an exponent here. So let's go on ahead and rewrite it, and let's move the exponent to the front like our rule says to. So just like these subtractions say to divide, exponents move to the front. So this is going to become 4 log 5x equals 8. Okay, well now I need to get all of this stuff by itself. So I'm going to divide both sides by 4. So that gives me log base 5x equals 2. Now I can rewrite this. Okay, so now I'm going to rewrite it. This one's pretty basic. I'm going to rewrite it as an exponential function. So my x and my 2 are going to trade places, and my 5 is going to be my base. So it's going to be 5 squared equals x. So 25 equals x. And let's go ahead and look at this last one. Okay, so first thing I see there is I see a plus sign. Plus means multiplication. So I have log base 12 of x times x plus 1 equals 1. Okay. I can either, get rid of that first, or I can get rid of the log first, or I can combine first. I'm going to go on ahead on this one and just get rid of the log base 12 first. So that I'm going to raise both sides using a base of 12. So that's going to cancel. So now I'm left with x times x plus 1 equals 12. 12 to the first power. Okay, don't forget that. Okay, well, looking at this, there's not a whole lot I can do. So I'm going to go on ahead and multiply. So I get x squared plus x equals 12. Oh, look, it's turning into a trinomial. Subtract 12 from both sides. X squared plus x minus 12 equals 0. Now I need to factor. Okay, so that's going to give me x plus 3, x minus 4. Oh, I lied. X plus 4, x minus 3. Okay, so when those add together, it equals positive. All right, so that's going to give me x equals 3 and negative 4. Okay. Now remember, the domain of a log cannot be negative. But on this one right here, since it's actually the domain of all of this stuff, okay, if I plug a negative 4 in here, I'm going to get negative 4 squared, which is 16, plus 4, or plus negative 4, which is 12. Okay, so if this was just log of x, okay, and nothing else with it, then that negative 4 would not work. But because it is with something else, then it's okay. But remember, our domain for just x by itself, okay, or for log is 0, greater than 0. Okay, so make sure that you keep that in mind when you're solving these. Okay, so let's plug it back in. So here, okay, 3 times 4 is 12. Okay? Or 3 squared is 9, plus 3 is 12. Okay, so both of those work. Okay, so plug them back in and check if you're unsure. All right, that is it for logarithms. You guys have a great day.